This video is about constitutional isomers. Constitutional isomerism depends on how atoms are organized in a molecule, i.e., a certain number of atoms can be arranged in different orders to give you different molecules, even though the chemical formula, i.e., the number of atoms present, remains the same. These two compounds or more that you could form are referred to as constitutional isomers. Constitutional isomerism is very common in organic chemistry, and therefore we need to show the structures instead of the formulas when we are discussing a molecule. The more atoms that are involved in a chemical formula means the more constitutional isomers there are going to be. This can be exemplified by looking at hydrocarbons. Here's a list of the chemical formulas, and here's the list of the number of constitutional isomers for each chemical formula. As you will notice, by 30 carbons, there is no way we could potentially draw all constitutional isomers of it. So this is becoming a very mathematical problem. We don't have to worry about that. At that point, we would have a specific molecule we are talking about, and we would not worry about other constitutional isomers at that point. However, it is completely reasonable to ask for all the constitutional isomers of a chemical formula with, say, 5 carbons, and expect to have questions like that. In fact, here's the question. Draw all constitutional isomers of C5H12. You may pause the video now, and here are the answers. Notice how there are only 3 isomers. You may have drawn more, but these are just from repeats, as showcased in this example. Here is another practice problem. Draw all the constitutional isomers of this formula. Hint, there are 4 distinct constitutional isomers. Pause now, and here are the answers.